Good morning, everybody. Hi, this is John Mullins, and thank you for joining today's webinar. We'll get started here in just one moment. All right, I'm going to go ahead and get started today. Thank you again for joining. My name is John Mullins, and today's webinar will focus on the Oracle Optimizer and its decision-making process when trying to choose or not choose indexes. And so that will be our topic for today, and we'll go through a little bit more detail what we're going to cover here in just a moment. You should be able to see my slide up on the screen right now. You can see there's an email address there. That's really for these webinars. That's really the best way to get a hold of us for questions that we might have in the short time frame that we have. So jmullins@themisinc.com. You can send me an email there, and I'll get back to you on that. Also, you see the website, www.themisinc.com. You can certainly go there and find out information about classes that are related to this. There's certainly a lot of classes to choose from, and I'll direct you out there in just a few moments. And then slides for this slideshow for today's webinar is available out there as well. If you also go out to themisinc.com, across the top there'll be a tab for webinars, and you can get a copy of the slides from today's presentation, and also in a day or so the recorded presentation will be out there as well. So feel free to visit that, and you can also follow us on Twitter @Themis Training and get some other updates on upcoming webinars and other training events that might be out there also. All right, so I'm going to jump right in here and get started. For those of you that have come to some of the other webinars or to some of our other trainings, welcome back. You know who I am. For those that are new, it's good to have you with us today. My name is John Mullins, and I'm coming to you from Themis today. We'll talk about Themis in just a moment as we jump into the webinar here. But I've been using Oracle for a little over 32 years, started with Oracle version 5. 5.1.22 in particular, as I worked at Boeing for 10 years as a developer and DBA, and also doing some training there as well. So I started with Oracle 5.1.22 on a DEC Ultrix system, supporting some factory support type applications. I'm also an OCP DBA and also certified technical trainer, and over the years have taught quite a few classes at varying levels, from just beginner SQL to advanced SQL, tuning, DBA type classes, and all those. And I'm coming to you today from Dripping Springs, Texas, down in South Central Texas, southwest of Austin, Texas, where it's a little bit cloudy today, but that feels better than 100 degrees for sure. As far as Themis goes, they've been around for a long time, providing all kinds of training. Some of you may have been to some of the training, whether it's Oracle, or you have some coworkers that have been to some of our other classes with Java or DB2, to name a few there. But if you go out to that themisinc.com, you can see a full list of the different training courses that we have there. So welcome back if you've been to those courses before. Otherwise, check them out. And like I said, all the webinar information is out there too. If you go to that website, click on webinars, all the past webinars are out there also. So if you've missed any of the past ones, scroll through there, kind of see what we got. There's a lot of Oracle ones on other tuning type topics, or on SQL or PL SQL or 12C new features, all kinds of ones out there for you. So just browse through there when you have a moment. As far as today's topic and courses that might be related to it, we do have a course called Oracle SQL Optimization for developers and DBAs. You can see that out there if you have an interest in that for you or your organization. I'll give you some information at the end. You can send some emails, or you can get that off the website as well, or some phone calls there. All right, here's what we got going on for today, and I know everybody's busy and it's running into your lunchtime, so I won't keep you too long. But like I said, the topic for today is we want to talk about, we've got indexes in place a lot of times, but sometimes the optimizer doesn't choose them, and so we want to talk about why that might be. There's going to be a lot of different reasons. We won't be able to go through every one of them today, but we'll go through a number of them, and some of them you might already be aware of, especially if you've taken the SQL tuning type classes from us before, or they may have been mentioned in some of our other webinars as well. All right, here's kind of the outline for today as far as looking at some of the different factors that may influence the optimizer. When deciding, should I do a full table scan? Should I do an index scan? What type of index scan? Is it an index range scan, unique scan, skip scan, full scan, fast full scan? Lots of choices for the optimizer there. Comparing that to, should I do a full table scan, or should I scan a partition if I've got a partition table? And so there's lots of things that go into it. So it could come down to the way our code is written and certain things that are in our code. I'll show you a couple there. We'll go through those pretty quickly. And then some other things like object statistics on both tables and indexes and partitions. Those can have an influence. And those are kind of the obvious ones there, are the statistics there. But sometimes people forget to check those types of things. Something called an index clustering factor. So we'll talk about that, comparing how the data is kind of organized in the index versus how the data is organized in the table that the index is based upon. And that can be an important influencing factor there. And then the one that most developers and programmers aren't aware of are certain parameter settings. So the DBAs can set up certain settings on certain parameters that can influence the optimizer one way or another. Is he leaning towards full table scans? Is he leaning towards index scans? These parameter settings can make a difference. Now, a lot of times these parameter settings, we just have them and just leave them at the default value. We're not saying to necessarily use these as a kind of a first resort to solving an index not being used type of problem, but the purpose of the presentation is just to kind of identify those things that could influence the optimizer, so that if you're going down your list, you're checking your code, you're checking the statistics, what indexes are really out there, you're checking the clustering factor and other types of things. You might also, if all else fails, let's take a look at those parameter settings too. And some of them are pretty powerful in influencing the optimizer one way or another there. So we'll want to do that. And I'll show you just a quick example, and I'll list what those parameters are when we talk about it later. And then maybe the estimated cardinality could be a factor too. So estimated cardinality being the estimated number of rows that a certain step within the execution plan the optimizer kind of expects to return. So he's looking at that cardinality to see how many rows are going to be returned as an estimate versus how many rows am I going to have to read through. And if that estimated cardinality is a certain percentage of the total, then either I'll use the index or not use the index. So we'll talk about that a little bit here too. And like I said, just as a reminder, if you think of any questions, go ahead and write those questions down, and you can send them to me at jmullins@themisinc.com. All right, so what I'm doing is I'm just going to show you some code, and this code is going to be very simple, and this might be stuff that you already are aware of, but I want to just go through the code real quick, and then we'll jump into those other factors in more detail following this here. So here's just a real simple query where department ID equals 10. If there's an index on department ID and it follows all the rules of indexing there, so he's checking the statistics. There's no join involved here. That can have a factor too. The type of join that it might do, even though we're not doing one here, could be dependent on some of our memory structure sizes like the PGA or the process global area. Depending on the type of join the optimizer wants to choose or consider, like a nested loop join, a hash join, a sort merge join. Obviously the hash join and the sort merge join, they got some work to do in that PGA, and if he's not able to do that, then he might choose a nested loop join, which is typically looking for an index, and the index might be on the foreign key column that we're joining on. So whether it uses an index or not might be dependent upon what join method he chooses too. This one's not a join, but I just wanted to bring that up there too. So in this case here, likely to use an index, and that's very simple there. And you look at it and you say, okay, yep, that I agree. Now, what about this one though, where department ID is not equal to 10? And these are all just real simple queries that I've run against an Oracle 12c database just to see what the optimizer was thinking there with all the default settings in place there. So the not, or in this case, the not equal type of thing. If we're talking about a B tree index in this case, a balanced tree index, which is one of the more common ones that you may be aware of, the not equal will cause the optimizer to not choose the index. Because you think about it, think about the index, and I mention this in my classes that I teach, an index in the back of a book. It doesn't tell you what's not in the book. It only tells you what's in the book. So same thing here in the database. If I say a not equal at this point, he's going to choose to do the full table scan in this case here. So I'm going to go through these codes real quick because the code's pretty simple. All right, how about these wildcards? So these can make a difference too as to where that wildcard character is. So we know we have a like operator here, and then we can use a % wildcard character or an underscore wildcard character there. If that wildcard character, like in this case the % is not the leading part of the string, then we have a good chance for the optimizer to choose our index. However, if it's is the leading part, let me go ahead to there real quick, like on this slide here, where last name like, and it contains an S, and I've got that leading either % or underscore on that. That'll also cause the optimizer not to choose the index. Okay, in some cases, he'll still consider using it. In other cases, he'll just automatically disqualify the consideration for it. He won't even think about it in other cases there. So it does matter when we're doing these wildcard searches where those wildcard characters are. And then the slide I went past here in just a moment, here it comes back up on your screen. This again has the S% on it, but I went ahead and threw this row function upper in here too. So many of you might already know, if you've been to the class or not, throwing functions against index columns. If those index columns are B tree indexes, that'll cause the optimizer to not choose the index. Now we could create what's called a function-based index, and then we'd have a better chance for him considering it. But when he sees a function against an index column, and it's just a regular B tree, he's going to disqualify the consideration of that index there. Now, if we make that a function-based index, so the index is based upon the result of the function and not just the value in the column, he won't automatically disqualify its use, but that also doesn't mean that he'll choose the index. So we may need to give him some further influencing him to get him to use that index, even if it's a function-based index. He might use it, he may not. One way that we can help him choose that function-based index is we can use, there was a new feature in Oracle 11G called extended statistics. And instead of creating statistics just on table data, like the columns that are in the table and the indexes that are on the table, we could also create statistics on either multiple columns if they're part of an index, or if there's a function. So instead of like this one here, instead of having an index on last name, which would get disqualified because of the upper, we could create an index based upon upper last name with that extended statistic feature. So if you haven't run into that, and if your Oracle, your queries are having troubles picking up either multiple column indexes, in other words, he's choosing single column indexes over multiple column indexes, or he's not choosing indexes, and like in this case, function-based indexes that are based on the results of functions, you may want to look at that extended statistic feature in 11G. And that's just an additional way to kind of influence the optimizer to use your index or not. All right, and here's one of those multiple column indexes right here. And so here I have an index on department ID and job ID. And in this case, this will be an obvious. You'll look at this and say, of course he would use my index, just like the first one there, because in the query there, I'm referencing the leading column of that multiple column index. And so it shows up. And so that one's pretty straightforward. We'll go right past that one. So, but I wanted to throw it in the slide there just in case anybody was wondering about that. But what if we look at this second example here, the same index on department number and job, but what if in our query we don't reference the leading column? Okay, way back when in Oracle 9i, Oracle came up with a feature called index skip scan, and sometimes it works and sometimes it doesn't work. So that's what we'll talk about here, because you may think, oh, in my query here I don't reference department ID, I just say where job code equals 20, and I'm just selecting last name from up above. So I'm not referencing the leading column here. So should it use my index or not still? And we're assuming here we don't have any other indexes for him to choose from also. So the answer is maybe. So just by not referencing the leading column, that does not mean he won't use a multi-column index, like in this case on department ID and job. He might use that index. He may not use that index. He has some considerations there. So if I were you, I would not rely on the fact that the skip scan feature is going to save you in this case, because the skip scan is very specific, very picky about, even on these multi-column indexes, the feature says, oh, you don't have to reference the leading column in order for Oracle to choose the index. Well, that's true. He'll consider using it. He won't automatically disqualify the consideration for it. However, this leading column, he's also banking on and looking at statistics on it about how many distinct values are there for department ID, in this case in the employee table. And if there are a lot of distinct values for department ID, then chances are he won't do the skip scan, because essentially what he's doing here, in order to maybe use this index where we say where job code equals 20, is he's creating these virtual indexes behind the scenes, and the number of virtual indexes is essentially going to be the same as the number of distinct values there are for department ID. So if that leading column, for example, were like the order ID in an order table, and I have 1,000,000 orders, and now I have 1,000,000 distinct values, chances are he's not going to do the skip scan. So the fewer distinct values I have in that leading column, the more likely he's going to do an index skip scan. In this case here, I tested this on 12C, even though it's a very simple query. And for my department ID in the employee table, there were 6 distinct values. And looking at the explain plan output, it did indeed choose an index skip scan. I was a little bit surprised that it did, because 6 is a pretty low number, so I shouldn't have been too surprised, but that's how often I typically run into the skip scan, which is not very often. So like I said, don't rely on just that feature there. You have to think about that leading column. The Oracle will recommend that if we have multiple column indexes and we're trying to figure out, okay, which column should I put first, which column should I put second, third, and so on, they'll say, well, your leading column, they would like you, we're not talking about skip scan now, just a plain old multiple column index, they want the most selective column first, which would be a primary key column. So that if you do a select where order ID equals 1,000, there's only one record in that table, in that index, that matches the 1,000 in that case. But that's kind of the opposite of the way skip scan works. Skip scan wants the fewer number of distinct to be first, rather than, so the least selective almost, but instead of the most selective. So we have kind of a struggle there because we want to build our indexes with the most selective first, but then we also would like Oracle to take advantage of the skip scan so we don't have to have all these extra indexes, right? Because the way to get around this is, oh, I can have an index on department ID and job code, but then I can also build an index just on job code. Well, now I've got two indexes there, which means for my inserts, updates, and deletes, that's a consideration. For the optimizer coming up with an execution plan, that's just one more index for the optimizer to consider. And so I'm adding more complexity there by adding all these other indexes, plus they're taking up more space, and so there's a lot going on there. So I just wanted to throw in this index skip scan. Just because I'm not referencing the leading column, that does not mean he won't use the index. In this case, he did indeed use it in an Oracle 12c environment. All right, how about parameter settings? And I got a little bit crazy on this one. This is a very extreme example, but this is the value I set it to just to let you know, and I'll talk about what some of those parameters are here in just a little bit. But one of them is this optimizer index cost adjustment. And like I said, these aren't things that we would normally change, although you may, if you got to the internet or you read some reference books by some very good Oracle authors, they may talk about, in particular, this particular parameter, optimizer index cost adjustment. It has a range of 0 to 1,000. The default value is 100 in this case. And what it does is it basically, if it's set to 100, that's telling the optimizer that the cost of choosing an index and the cost of choosing a full table scan are the same at 100 for a value for this parameter. If we lower the value for this parameter, that's telling the optimizer the cost of choosing and executing an index is less than the full table scan. So the lower we make the number, the more likely he is to choose an index. The higher we make the number, the less likely he is to choose an index. So here's a scenario. You've got some query you're running. You know you have indexes in place. The optimizer's not choosing those indexes. You've looked at some of the things we've already talked about as far as your code, and you've looked at statistics. You looked at what indexes are available. He's not choosing those. At some point in time, we'll want to know what these parameter settings are. And maybe you have the privileges to be able to do that. Maybe you don't. But you can look at a view called $parameter and see what the setting is if you have privileges to select from it. Or you can ask the DBAs, what's the setting at? Because I'm having trouble getting the optimizer to choose an index out there. And this won't be the only parameter out there, but this will be one of them that you may want to check. So I set this one just to really be extreme and force the optimizer. I set it to 1,000 in this example, which means that the cost of doing the full table scan is going to be a lot less than the index, and so he'll likely choose the full table scan, which when I ran this through to Oracle 12c, he did indeed do a full table scan. So you can see I tried to keep the query the same and change a lot of these influencing factors around it to see what the optimizer would do. So we may want to check that parameter there. And we'll see some other parameter settings here in just a few moments. But they could influence that. All right, so those are just some real simple code examples there just to let us know. And there could be some other code examples out there as well. But here's some other factors outside of the code here. And many of you are aware of the statistics that are out there. We can have statistics on tables. We can have statistics on indexes, on partitions within tables. And these statistics are usually generated through some batch job that runs nightly or weekly, depending on your data. The DBAs are typically responsible for setting up the batch job. It goes out there and generates statistics like on number of rows, if it's an index on the number of distinct keys or the number of leaf nodes in a B tree index. All kinds of statistics are available. So when you run your query, the optimizer is going to check these statistics at some point and say, okay, based on the statistics and this other information, here's what I'm going to do. So if you've got missing statistics, if you have statistics that are inaccurate, then that could cause the optimizer not to choose your index in that case. If you've got, for some reason, if you have statistics on a table but not on an index, or vice versa, that could mess up the optimizer in choosing whether or not to choose an index or not. So those are all important things there. We can see, based on the statistics and everything else that go into the execution plan, the optimizer is going to come up with a cost. So if any of you are used to running the execution or explain plan utility either from SQL Developer or Toad or from SQL Plus or wherever you're running it from, there's a cost associated with that execution plan. And that's basically the one he gives you is the lowest cost, or usually it is, we'll say it this way, is the lowest cost out of all the alternative plans that he considered along the way. And that cost is a representation of estimated resource usage, whether it be CPU or I/O or memory or whatever it might be there. Now, as far as the statistics go a little bit further, we know that inaccurate or missing statistics could be a bad deal. So, Oracle was going to say things like, make sure your statistics are up to date and accurate. That gives the optimizer, the best information, the best data to come up with a good execution plan. But we know that generating statistics could also invalidate plans that are already in memory in the shared pool on the Oracle server. So some people are a little bit leery about changing statistics too often. They may only change statistics or update statistics if they're missing. They may only update statistics if the value I'm going to calculate is either more or less than a certain threshold. Like the default for staleness is if the data is off by more than 10%, then I want to regenerate or recalculate or update my statistics in that case. We can view those statistics, and you see in the third bullet on this slide here, we can view those statistics in views like all underscore tables, all underscore indexes, or all tab partitions. And by default, you don't need any special privileges to do that. So if you have a user ID and a password into an Oracle system, these views do not take any special privileges. You can go out there, check the statistics, look for missing statistics, look for statistics that are off by more or less than 10%. And even if you can't regenerate the statistics yourself, and we're talking about both production and non-production environments, then maybe contact somebody who can and let them know, because it could have been an oversight, it could have been a job that failed for some reason, and we need to get that taken care of as soon as possible. So, statistics are important as an influencing factor into whether or not the optimizer will use an index or not. I was just in California the last couple of days this week, and I was doing a class there, and one of the things in one of the exercises we were doing, they had some tables, and they did not have any statistics on their tables. These are brand new tables. The statistics had not been generated yet. They were running their queries through the explain plan utility and getting certain plans that they could look at. When they put statistics on, the plan changed totally. It wasn't even close to what the other plan is. Now, sometimes you'll put statistics on and it'll take the same plan. With statistics there, now all of a sudden it was picking up indexes and choosing to do indexes. And if he's choosing to use an index, then he chose to do a nested loop join, which is typical of that. And so the index and these statistics could be a big deal here. So keep that in mind. And the views that you can look at there. Now, within each index, we have something called, this is one of the statistics that are out there, something called a clustering factor. Okay, you can see here what that represents, but he's basically looking at, if you look at a B tree index at the leaf node level, whatever you're indexing, like the last name of an employee or customer, is by default in ascending order at that leaf node level. Now, as he's scanning the index to go to the table with the row ID that he gets from the index, is the data in the table in a similar order to the index order or not? And that's what the clustering factor is trying to tell us here. He's comparing the order of the index to the order of the data in the table. And that's going to be an important thing there. So we're trying to see how ordered the data is in the table, or is it very scattered and random? What is it in the table there? These top two bullets here, I think, pretty well explain it, what it actually is here. All right, let me see here. It looks like my slide got all funky there, so let me bring up that slide again here for you. Sorry about that. My slideshow disappeared. All right, so here, let me bring up the clustering factor here. I'll get that back here for you here. Just 1 second. Let me bring up there we go. You should be able to see that there. All right, so like I was saying, that these top two bullets here, I think explain it pretty well. So if we're looking at this clustering factor, remember, this is generated by somebody generating statistics out there. If the count or the clustering factor value is close to the number of blocks that the table represents. Remember, in Oracle, the lowest piece of the architecture is a database block, and by default it's 8K. And so even if I'm just looking up your phone number, I have to at least read one block to do that. And so the table's made up of a number of blocks, and within those blocks are a number of records there. And so if the clustering factor is close to the number of blocks that the table makes up, then we have a good order, a good correlation between the index and the table. However, if the count or the clustering factor value is close to the number of rows, so we're comparing number of blocks to number of rows, then the index isn't as ordered there. So in other words, I'm reading a block in an index. I'm doing an index scan, and I'm going through the records in the block, and I'm grabbing row IDs. If those row IDs point to blocks in the tables that are scattered and random, that's not a very good clustering factor. If they're more aligned with what we're seeing in the index, then that's a better clustering factor. All right, and if we go to the view all underscore indexes, and there'll be a column in that view called clustering factor that's generated, the value for it's generated when statistics are generated. We can kind of see what that is there, what that value is, and then compare it to the number of blocks in the table, which we can get from all underscore tables out there. So clustering factor can be a big influencing factor too. So if your clustering factor is off and you have an index there and you're running your query and you're seeing he's not using it, it might be because of this. Right? Here's those parameter settings from earlier that I was talking about, and we looked at that. I had that example of the optimizer index cost adjustment, but there's a few others in here too, and maybe a few others that I don't have listed here. But DB file multi-block read count. Like I said, most people are just going to leave these at their default values, but they may need to adjust them. It's kind of like with hints and such. If I can't get something to choose my index, then I may need to adjust these, even just temporarily, until I come up with a better solution maybe. So the DB file multi-block read count, on default on a lot of systems it's set to like 128. And what that means is if I'm doing a full table scan, within a single I/O, I can read 128 blocks. So think about that query. I'm doing a select, and there's an index on the columns that are in my query, and the optimizer is saying, should I use an index or should I do a full table scan? Well, unless he's doing an index fastful scan as his access method, if he's doing any of the other index access methods like index range scan, for example, he can only read one block at a time. So he reads a root block, he reads a branch block, he reads a leaf block, gets a row ID, goes to the table block. He may have to read, in that case, a minimum of 4 blocks. But what if my table, let's say, is made up of 50 blocks, and my DB file multi-block read count is set to 128? So Oracle's saying, in that case, in a single I/O, I can read 128 blocks, and the table's only 50. So if I do a full table scan, I could do that in a single I/O, whereas the index took at least 4. So I'm not going to use your index. So with that particular parameter, the higher it's set to, that influences the optimizer to consider a full table scan more. The lower it's set to, he'll kind of lean towards the index more. So like I said, if you're having trouble with the optimizer choosing your indexes, one of the things on your to-do list to check on should be, what are these parameter settings? That way you could at least cross them off your list and say, well, it's not this, it's not that. Or you could say, hey, this isn't set to its original default value, and that might be a reason the optimizer is behaving differently. We talked about the optimizer index cost adjustment. It's set to 100 by default. The lower the value is, the more likely he is to choose an index, because that indicates to him that the cost of doing an index or reading an index is less than the cost of doing a full table scan. Some of your authors out there have been, over the years, have seen some of their papers or books on these things, and some of them will say this is a good parameter to reset the default, maybe set it to 30, and in some cases I've had to set it as low as 10 just to get the optimizer to use my index, because that's like saying, instead of something cost $1, now it costs a dime. Do you want to buy it? Well, in that case there, the optimizer said, hey, that's a good price for an index, a dime. I think I'll use it now. Now, that may not be the best long-term solution for me, but it tells me that I can at least get to a point where the optimizer will choose my index, and now I can figure out what else is going on in the system that I may have to do that. The optimizer index caching by default is set to 0, but just so you know what it is, this is the percentage or the likelihood that if the optimizer wants to use and read index blocks, that he'll find them in memory. Okay, so in memory, there's a memory structure called buffer cache, or database buffer cache, or data block buffer cache. People call it different things. And it contains all types of data. It has table data, index data, undo data, all kinds of flavors of data. So it does have index blocks up there too. And this is the likelihood that he'll find them there. So it's set to 0. So that kind of, pushing him towards doing the full table scans, because he's thinking, oh man, if I choose an index, I'm not going to find it in memory. I'm going to have to go to disk, put it in memory, and then I can take advantage of it. But that's not the only factor. So the fact that it's 0 doesn't mean he'll never choose an index. It's just one factor. And so the 0 doesn't typically hurt us. But if all else fails, and I've tried everything else, we may try to increase that parameter. It can go up to 100. So it can go from 0 to 100, and that's telling it, hey, there's a 100% chance you'll find the index block you need in memory at that point. And that might help him choose that index a little bit better. And then lastly here I have this optimizer mode, which by default it's set to all rows, which is for best throughput, which means, come up with the best plan for processing a lot of data. It's particularly good for batch jobs or big reports that we might be running, but it's not necessarily good for getting data back right away like we would with an index. So all rows may influence the optimizer somewhat to not choose our index. First rows might choose the optimizer to use the index more. First rows kind of goes with the nested loop join. So then we've got that coming into play as an influence as well. Should I do a nested loop or a hash join or sort merge join? Those last two typically don't use an index or don't expect an index there. So the combination of all those could influence the optimizer to not use an index. And that's what this webinar is all about. What are the factors that could cause him not to choose an index? We know there are a lot more factors out there that will influence the optimizer, but today we're just talking about indexes only, and so there's lots of other things out there too. And if you have any more interest in that, if you haven't taken our SQL Optimization class, we talk about it in there a lot. All right, and then lastly here, so we're almost through in there, hang in there, we have the estimated cardinality. So if you've ever done an Oracle, or any other vendors too for that matter, an explain plan, or ran the explain plan utility, and you're looking at the output, you may have noticed there, in the Oracle one anyway, you may notice a column that has a heading that says rows on the top of it. It's usually right next to the plan, depending on how you run it. But it says rows. and that's the estimated cardinality, which is as he's doing each step in the plan, each step will have an estimated cardinality, which is the estimate on the number of rows for that result set for that step. So if he does a full table scan, his estimated cardinality, if the table has 63 rows in it, the estimated cardinality should be 63 if he's not applying a filter to it. If the estimated cardinality is off for some reason, in other words, it's doing, instead of 63, it says 6,300, or it says 5, and it's way off the real what it should be, then that could cause the optimizer to then change his plan, alter his plan, come up with a bad plan because the data that's being fed to it is inaccurate. Now, we could get a bad cardinality because maybe statistics are off for one thing, or if I have missing statistics, remember, some of you already know this, but if I have missing statistics, then he may go out and do a dynamic sampling to get some temporary statistics that he could use in coming up with the execution plan. And depending on the sample, some samples are good, some samples are bad. The sample by default is a very small sample, and he's going to assume that sample represents the rest of the data in the table, which if it's a bad sample, like if all the department IDs in that sample are 20, he's going to assume that department IDs equal to 20 are going to consume most of the table, which may not be the case. And so then he comes up with a bad plan. Now there's as we're looking at these execution plans, you might be doing it with, Oracle has a package called DBMS_XPlan, and in that package there's a program, a table function called display. That'll show you the number of rows or the estimated cardinality, but you can also do, instead of display, you can also do display cursor, and then as part one of the options there, tell them you want to see what's called all stats. And what that'll show you in your explain plan output is not only the estimated cardinality, but the actual cardinality or the actual number, and you can compare the two. So if you see 5 for the estimated and the actual was 50,000, we've got a problem. Okay, in a bad way there. So you can use that. So that's in that DBMS_XPlan package. You may want to look into the program called display cursor, which means now we're looking at an execution plan that's not theoretical, but it's an actual plan. That's how he can come up with the actual rows also. And he'll display both. Here's the estimated rows, here's the actual rows. And what we're looking for is a big difference there. So you may want to look into that a little bit further, because if this number's off, then it could cause the optimizer not to choose our index when we were expecting him to, or it to. All right, so those were just a handful of the factors that could cause the optimizer not to choose an index that we were expecting the optimizer to choose. So remember, it could be your code, it could be statistics, it could be the cardinality, it could be database parameter settings, just to name a few there. And there's going to be some more for us to check into. Oracle's a big, complex system, and there's a lot of things that could influence them. Some things that have to do directly with indexes. Some things, if I'm doing a join and I'm expecting him to use an index, depending on the join method he chooses, like a hash join or sort merge join, he may not choose to use an index for those type of joins, but for the nested loop, he would. So, the join method can also influence the optimizer on whether to use an index or not as well. So if you chose to do something like a hint, and that's one of the other factors here, what if you used an index hint? And now that caused him to do the nested loop. Or let's do it the other way around. Let's say you did a use NL hint, a use nested loop hint. And the optimizer said, hey, I think I'll do that. Well, once he decides to do that, one of the things he's expecting is an index on the foreign key column. And so now all of a sudden he uses the index, not because you told him to, but because you told him to do a nested loop join. Now, just remember with the hints, most of the time he's going to take your hint if you don't have any syntax errors and it's well written and things like that. But there are factors on hints too that for whatever reason, if the hint contradicts itself, the code itself, or if there's a syntax error in the hint, he'll just ignore it in that case. But most of the time, he's pretty good about taking the hints there. But remember, it's not 100% thing, but it could be pretty close to that, and has lots of factors for him to maybe not use a hint there. So remember, there are other factors besides what we talked about today that are indirectly could influence him as well, as far as not using your index there. Now, if you had any questions that came up during the webinar today, feel free to send them to me at jmullins@themisinc.com. If you're looking for some more information, here's some upcoming webinars that are mainframe type related here. There's a good one here on DB2 SQL PL array processing. In Oracle, instead of SQL PL, we have PL SQL. It's the other way around, and we have 3 types of array processing or collection processing in Oracle. We have V arrays, nested table arrays, and associative arrays. Here's DB2's version of that. And then there's also one coming up. That's in October. And then we have one in November on CICS and the DB2 interface there. And that should be a good one as well on November 16th. Now, if you want some more information about classes that are out there, go to themisinc.com. John Cacavel will be happy to talk to you about, get you in a class either for yourself. We do classes online. We do classes in person. We have public classes. We have private classes. He'll be happy to get you set up with that. Remember also to go out to our website, click on the webinars tab. You can see today's slides should already be out there. And then a recorded presentation from today should be out there in a day or so. And plus, all the past webinars are out there also. So you can view any of those. There's a whole bunch on Oracle stuff and other programming, other mainframe stuff, all out there also. But other than that, thank you for attending today's webinar. Everybody have a good end to your week and a good weekend coming up. And watch our website and your email for future webinars that are coming up and future classes that might be scheduled. So thank you again for attending, and have a good day.